Наш микрофон слышно? Dear colleagues, so let's start our webinar today. We're going to talk about interesting topics. And first, before starting, I want to pay attention that we have a simultaneous translation from English to Russian and from Russian to English. Уважаемые коллеги, начинаем наш вебинар. Хотела бы вам в самом начале сказать, что у нас организован синхронный перевод с английского на русский и с русского на английский, поэтому воспользуйтесь опцией перевода, если есть такая необходимость. Внизу экрана вы увидите такой глобус, да, и там выберите перевод с английского на русский или с русского на английский. So please use these translation options. It's a symbol of the globe that you can find on the below the screen on the right side, and you can choose the translation that is convenient for you. Because we're going to today use both English and Russian, so please change it according to your preferences. To start and opening this webinar, I would like to give the floor to our colleague from the OECD, Pelin Atamer. Pelin, please go ahead with your welcoming speech.
Thank you very much, Madina. Good morning or good afternoon to all, depending on where you are joining us from. And thank you very much for connecting in this webinar. So my name is Pelin Atamer. I'm the head of the OECD-led Sustainable Infrastructure Program in Asia, or SIPA, in Central Asia. And this is the third regional webinar that our partners of the University of Central Asia are organizing under our program. So today we will discuss analysis of opportunities and challenges for the decarbonization of infrastructures and emergence of low-carbon energy systems across Central Asia and Mongolia, as well as policy reforms that can help address challenges and realize opportunities. So as you know, this region is one of the most carbon and energy intensives in the world, and this is largely due to outdated and inefficient infrastructure. So that much is well known, I think, to all. And what we want to discuss today is the policy path to energy systems that can be less carbon intensive, that can support better productivity and better environmental goals, as well as the reaching of national direct contributions and low carbon commitments across Central Asia. So in particular, we will discuss a very insightful study from the University of Central Asia on the status of policy frameworks that can support the decarbonization of energy systems, as well as the opportunities associated with renewable hydrogen, nascent technology that will be needed to achieve net zero by mid-century. Through this example of hydrogen, I think we can really see this very interesting discussion to be had on a new model for sustainable growth and finding a new model integrating a new technology, a new approach with more energy efficiency, more low carbon technologies that again can support decarbonization, but also pose the question of new growth models, new models for generating economic and social benefits, including at the subnational level, with new job creation, new revenues from new activities, but also more indirect economic contributions such as fiscal revenues and even other models for generating wealth locally and nationally. And so the conditions for creating these new models will be, I think, extremely interesting. Yesterday, I attended a regional stakeholder consultation on energy conductivity in the region, and renewable hydrogen was very much prominent on the agenda, including for enabling the trade of this low carbon technology. So I think that this discussion resonates with what we want to achieve today, which is not only to discuss the potential for policy reforms in the different countries of the region, Thank you. But also creating a regional community of practitioners, of policymakers, to think of how to make this a collective, how to build a collective approach to this question. How to build synergies and how to enable one another to advance, to move forward this agenda. So to conclude, and before we move to the substantive discussion, I just want to thank again very much all the partners of SIPA, and in particular the University of Central Asia, for organizing this webinar. And thanks again very much to all that are joining, and to the government of Germany through the International Climate Initiative that supports this work and makes it possible to organize these discussions. Thank you very much, and have a great webinar.
Thank you very much, Pauline. And also I would like to give a floor to our colleague Konat, if he's still here. If not, I can also continue welcoming from the side of our University of Central Asia.
Madina, you can continue. Thank you.
Okay, thank you, Konat. So we would like to welcome all of you in this webinar, which is the third one. So because our project includes capacity building for civil servants, and we wanted to extend the knowledge to the larger expert group, we launched this webinars last year, and we were pretty successful. We had first webinar was 30 people, then it was 60. So that's why we are trying to continue this kind of habit. So if you really would like to present something during our webinar, if it's related to sustainable infrastructure, you're welcome to write us email and send your topic of the study and the summary of your study. And we are actually hosting the summer schools. So that conducted already 2 summer schools, and one is coming. During the summer schools, we transfer the knowledge, our international partners transfer the best knowledge on the planning, investment of sustainable infrastructure. And this is also partly the opportunity for experts to take part in the conversation. So I would like to invite the OECD economist, Luc Macle, for his presentation that based on the study they did in Mongolia. It's about the renewable hydrogen strategy in Mongolia. I just want to mention to our speakers that you're going to have 20 minutes for your presentations, and I will take care of timing. So Luc, please don't take it personal if I will interrupt you or give you a signal that you have less time. So please go ahead, and don't forget that we were going to have a special time for questions and answers. So no worries if you didn't say everything during your speech. You'll have additional option during this Q&A to continue it and to provide some clarification. So please go ahead. The floor is yours.
Excellent. Thank you so much, colleagues. Can I share my screen, please?
Yes, of course.
Okay, great. Let me just share screen. Okay. And I'll trust you to let me know when you can see this. I think
we can actually see the.
No,
we see your notes.
Okay, so I often have this issue. Sorry, give me 2 seconds. I'll try and get this into. Sorry, guys.
No worries.
Very well. I'll maybe just present like this. Really. There we go. Is that okay? This is fine. Okay, excellent. Okay. Yeah. So thank you everyone for organizing this. It's really a great honor to be able to participate in this event today. I'll just minimize the this. Yeah. Okay. So it's a real pleasure to be able to speak with you today and to present some of the work that we have been doing over the past really the past 12 months or so, specifically over the past 6-7 months. Have been quite an intense piece of work where we have been supporting the government of Mongolia with the development of a national strategy for renewable hydrogen. And it's a piece of work which has obviously a great deal of relevance for Mongolia, but where there's a lot of learnings that are pertinent for many of the countries that SIPA works with, that are present today. I also want to say thank you to many of the stakeholders who are actually in this call who helped us develop this this piece of work as well. So for a little bit of context, this project arose because there was a private sector interest in Mongolia in developing renewable hydrogen, green hydrogen. So hydrogen using renewable energy and water electrolysis. This was a project. And it's something that has attracted the attention of the government. The government has integrated some thinking about renewable hydrogen into some of its policy plans and its strategic plans. And there are opportunities. There are opportunities for Mongolia, as we'll come to, primarily due to the high potential of combined wind and solar, and proximity to a potential export market in China. And so what this work was trying to do was to really kind of look at what was the potential for renewable hydrogen development in Mongolia, to have a look at some specific issues that were particularly relevant to the country, namely these water, hydrogen nexus issues, and to develop a set of policy recommendations that could underpin or inform a strategy going forward. And to do this,
sorry,
yes?
Can you speak not so fast, because
Of
we
course,
are
sorry. Of course.
difficult for.
No problem.
Thank
So
you.
the approach was we undertook a series of interviews or focus groups. We conducted a long, intensive mission to Ulaanbaatar. We had many online discussions. We also spoke extensively with the projects themselves, with international financial institutions, the whole ecosystem around this. And we focused our work on essentially 4 main areas where we felt that a strategy could really help the Mongolian government going forward. And this was around how to align the innovation and industrial policy framework, how to improve the investment framework for renewable hydrogen, how to ensure the sustainable use of water for hydrogen production, and then how to bring this together in a strategy, and what kind of governance and steering mechanisms would be necessary. So just as a very quick recap, why are we talking about this? I mean, essentially it is because we see that in the kind of net zero future, there are certain hard to abate emissions, particularly in the industrial sector, where the technologies that currently exist, electrification, will not be sufficient to achieve net zero emissions in those sectors, and they need new technological solutions, of which one is hydrogen. And this means that going forward, demand for hydrogen is going to increase, and this will create opportunities for countries that can competitively produce it. Right? And to competitively produce it, one of the things that you need is to have exceptionally good, reliable, renewable energy potential. And this is something that Mongolia has. It's also something that other countries in Central Asia have. And in Mongolia, you can see that in particular, the combined wind and solar power is very, very high in the south of the country. So should Mongolia be able to develop the renewable energy infrastructure necessary for electrolysis, and should it be able to have access, sustainable access to the other key input necessary for hydrogen production, which is water, a question mark here, then under certain policy conditions, Mongolia might be able to produce hydrogen at sufficiently competitive cost to be able to be an exporter of this technology. Now, of course, there's also a domestic rationale for this, and Pauline mentioned, the sustainable development of industrial infrastructure, industrial development in the region, and this is as true in Mongolia as elsewhere. And what we see is that whilst the industrial sector in Mongolia remains relatively small, it is growing, and like in other countries across the region, the government has a commitment to expand the industrial sector. And in Mongolia, that expansion is primarily driven by the mining sector. And the mining sector is an area which is is very hard to abate. There are certain emissions which are difficult to address. And hydrogen is one of the technologies, it's not the only technology, but is one of the technologies that could support a more sustainable development of the mining sector, and importantly, support the development of the processing and higher value adding parts of the value chain, which the government hopes to bring into the country. So this is not just about the mining footprint itself, also the moving up the value chain and the types of technologies you need to ensure that's sustainable. And hydrogen is one of those. So we had some kind of core questions that we're looking to answer. As I mentioned, what are the policy conditions that are necessary for a renewable hydrogen industry to be developed? How can Mongolia ensure that this industrial development is sustainably, environmentally sustainable? And how can it ensure that the development of a hydrogen industry also supports the domestic industrial ecosystem and its decarbonisation? And we focused on these three areas. One was aligning the science, innovation, technology policy with low carbon outcomes. The second is this question of attracting investment, mobilizing finance for renewable hydrogen. And the third was ensuring the water use was sustainable. And as a quick point of parenthesis here, the rationale for this was that many of the policies and many of the actions that would be necessary for the government to ensure that the country was well positioned as a potential producer of hydrogen would also be necessary for the broader industrial decarbonisation of the economy. And so there are a lot of no-regret policy interventions that are part of these three areas, which make sense regardless of what the government does next with regards to its hydrogen ambitions. So in the question of the science, the SDI aspect, the science, innovation, and technology, well, what do we see? We see that innovation in this particular technology is very concentrated within a small number of large firms across a small number of economies. And essentially what this means is a key component of a policy framework, of a strategy, is going to be, well, how do you transfer this technology on terms which are understandable and fair to emerging economies such as Mongolia? Another one is, how do you stimulate demand for these technologies domestically? Offtake is a critical component in getting some of these hydrogen projects to a final investment decision. And that's not just external offtake, it's also domestic offtake. And also you have a well-developed SDI policy framework, but it's not particularly aligned with the government's overall low carbon objectives. And so there's a question then of how do you direct a limited set of public resources towards science, technology, and innovation activities which further the ambitions of the government in terms of its low carbon objectives. And a set of recommendations are developed on the basis of this. They're around things like adding direction to innovation through R&D tax credits, other types of innovation agencies, the creation of a technology transfer unit, expanding the use of concessional finance that can accelerate the deployment of these technologies in target industries, and stimulating demand through things like effective carbon pricing. So this is a kind of set of recommendations, a snapshot of the recommendations that emerge from that. There's a quick zoom here on one of these issues around technology transfer. Technology transfer really emerges as one of the key points in this work. And this is transfer both internationally. So how do you transfer the intellectual property and the technology and the capacities necessary to use it from those innovating economies to the emerging economies that will deploy it? And so there are mechanisms in place to support that. Things like Japan's joint crediting mechanism, which is on the left-hand side here. But it's also, if one assumes that the government improves the alignment of its domestic SDI framework, about improving the transfer of what's going on in the Mongolian research base with the industrial firms in Mongolia itself. And so there's a domestic aspect to this transfer, and there's an international, and both of these things emerge as key themes in the work. The next set of issues was around investment attraction, mobilizing finance. And the rationale for this is essentially that in any emerging economy, to get some of these low-carbon industrial projects off the ground, there is a need to massively mobilize finance. and in large part external finance, both private and development. And so one has to understand what are the barriers to mobilizing and getting that finance into Mongolia or into any other emerging economy for that matter. And so what we see is, well, the barrier is not necessarily one of statutory restrictions. Mongolia, Kazakhstan has a relatively open statutory framework, that there are actually some incentives already in the policy framework for low carbon technologies, but they're not strategically applied, right? So they're not applied in any particularly directed fashion. There are issues in the business climate and the investment climate that don't pertain to regulations, but pertain more to trust in the government, trust in the public sector. And this is really important because many of these low carbon industrial projects, such as hydrogen, often rely on some kind of public-private agreement at the outset to get them going. And so when there's a lack of trust, it really increases the risk of the project. There are, of course, the signals about the lack of coal phase out and what that means for essentially the price of carbon and the impact that has on the attractiveness of these lower carbon projects. There's a lack of specific de-risking instruments for renewable hydrogen, and this is something which emerges as a key question for many low carbon technologies. How do you de-risk these investments early on? And how do you do so in a way which is financially sustainable for the government? Because it often implies some role being taken by the government to de-risk some of these investments, and there's a balance to be struck here. And of course, infrastructure. Both hard infrastructure, the lack of pipelines, the lack of storage, this makes complete sense. The industry has not been developed. But also the soft infrastructure. How do you ensure that the regulatory framework, the certification, the licensing, all is conducive to the development of this technology and its application in domestic industry? And so again, a set of recommendations follow from this. It's both about raising the profile of Mongolia. So, for example, integrating this low carbon investment mission into the newly developed Mongolian IPA, Investment Policy and Investment Promotion Agency. Formulating a really clear strategy that clarifies what the long-term objectives of the government are in terms of its coal expansion versus renewables. Considering a slightly more strategic use of things like import duties and tax relief for low carbon technologies to really improve the kind of cash flow and the capital costs early on in these projects. Mapping what some of these hard infrastructure needs are for these projects, ensuring that the government has a vision for this, and also monitoring the development of the regulations that are happening outside of Mongolia, because this is a nascent regulatory area. It's something which is constantly in flux, is developing, and there's a need for both the project developers and the government to stay abreast of those developments and to make sure that the public policy interventions domestically align with what's going on externally, particularly if the country has an ambition to export the hydrogen or its derivatives. Here, there's a small zoom, and I won't linger, but just on renewable energy, because I think it can highlight some of these investment issues, because what you see in the left-hand side is an index that's created by the OECD called the FDI Regulatory Restrictiveness Index. And what you see is that essentially Mongolia is not particularly restrictive, not compared to many other OECD and non-OECD economies, but yet the actual investment into the renewable energy infrastructure, which is absolutely critical for these hydrogen projects, is not happening. And at the same time, what's happening is investment in coal continues. And when you look at how the power sector plans to expand over the next 10 years, you see that much of the additional capacity is going to come from coal. And so here what you have is not a de jure barrier to investment, but a kind of de facto one, because the signals coming from the government about its long-term commitment to a low carbon transition are very mixed. And this is something that investors look at. The last area, and then I'll wrap up, I hope I'm still on time, but please do cut me off from going over, is around water. And this obviously emerges as a critical issue in Mongolia. Mongolia is a landlocked country. There is a geospatial mismatch between where the surface water is, which is primarily in the north, and where the renewable potential and the markets are, which is in the south. And so this means there is this question of, well, How do these projects access water? How much water do they need? What are the technologies that can enable them to use that water in the most efficient way possible? How does that, what kind of implications does that have for the social, the political acceptability of the project? And these are all things, these are all themes that really come out of this work, which I think was quite novel for this hydrogen work in Central Asia, really looking at this water hydrogen nexus, because it's something which, you know, it comes up time and time again, both from the investor's point of view and the public policy point of view. And there are recommendations again that come out of this. It's about looking at, well, how do we anticipate what those water needs are? How do we enable policymakers to have a really clear evidence-based understanding of what the water implications are for hydrogen, and also to situate those needs in the broader industrial context? So looking at mining, looking at how mining uses water, look at what the long-term implications are for a coal phase out on competing uses on water, and having this slightly more strategic long-term vision. Considering a more kind of cross-sectoral approach to water infrastructure development, how can you co-locate water infrastructure that needs to be developed for hydrogen with other industrial users? And so there's a set of recommendations that come out of that. And this is one of the last slides, and here it's just to kind of put some figures on this. So what you see on the left-hand side is water demand from some potential renewable hydrogen projects in Mongolia versus other sectors. And so what you can see is that when the numbers are relatively small, when we're not talking about a utility scale hydrogen production, it probably is not going to have a huge impact on the water resources. But if you follow it through to its logical conclusion and you have a utility scale hydrogen production, well, there the questions around the sustainability of water really are a little bit more uncertain, and that's where a lot of more information and evidence is necessary. And so just to wrap up, these areas map over the report. The report is split into 5 sections. You have an introduction that sets out the rationale for looking at this. There's a chapter that looks at the SDI aspects of it, the alignment of the innovation policy framework with these low carbon developments and their use in industry. Looking at the investment policy framework aspects, how aligned is that with attracting and retaining investment into these low carbon hydrogen projects? Looking at the water issues, and then bringing that all together in a set of holistic recommendations. So not being overly specific on individual technologies, but having a suite of recommendations, which really hopefully will form some kind of basis for moving forward with a strategy. And so each of these recommendations has a number of sub-recommendations with more specific points, but here's just to give you a sense of thematically what we're looking at. And then last but not least, what happens next? Well, this is something we're in discussions with our Mongolian stakeholders. You know, as it's set out in the recommendations, the kind of next steps are really about creating some kind of steering platform so that this work can be taken forward, having a kind of timeline for developing this strategy, but also for monitoring, reviewing it, adjusting it if necessary, and perhaps defining some kind of shared vision about what this hydrogen industry can do for Mongolian industry and also for its other policy objectives, whether that's decarbonisation, diversification, regional development. And this is really the kind of next steps for Mongolia. And on this, I will pause. I realise I've gone right through this fairly quickly, but hopefully we'll have some time for some questions after this. So thank you very much for your attention.
Thank you very much, Luke, for exciting presentation and the comprehensive work. Before we start questions and answer session, I just want to say that colleagues, you can post your questions on the this chat area, or you can raise your hands and we will give you a floor. But from our side, we can say that adding to the recommendations from the OECD side, of course, all of us, we understand the hydrogen is actually can be a potential source for emission-free electricity, which is in high demand in the Central Asian region. But at the same time, we have an opportunity to create the regional knowledge network to do it together, because hydrogen is something new not only for Mongolia, but for all the Central Asian countries. And unfortunately, we do have very limited capacity, and we don't have enough hydrogen production engineers, hydrogen purification specialists and storage experts. So, and also we have a shortage of the chemical engineering and people knowledgeable in, you know, all this material science. And we conducted interviews last year when we did a study on decarbonization of transport with Mongolian experts, and we figure out that unfortunately there is external experts come and they actually do some consultancy projects, but they do not really do a knowledge transfer. And therefore, we are, as a knowledge institution, we're here and we're opening the floor, and there is a really need for capacity building. Let's come together and do it among our countries and create this really kind of Central Asian knowledge hub for the hydrogen potential. And we are very, you know, open to this, and we think we should develop some focused educational programs, maybe on the master level, which can fill the existing gap. We've lost translation. Can you check translation, please? So do you have any questions? If not, I wanted to ask about something related to this, you know, the human capacity. Yeah, I'm just checking. Okay, we have one question from the Muratbek. Can you turn his mic on, please, Kanshai? Yes,
Hello,
please.
good afternoon.
Yeah, we can hear you. You can ask your question.
All right, yeah,
Please
thanks a lot for the talk. Can you hear me?
Yes, can you introduce yourself shortly before you ask your question?
Sure. Yeah, Muratbek Aljabayev, Associate Professor at Nazarbayev University. My work is also in energy, including renewable energy, formerly UCA faculty. Yeah, thanks for the talk. To be honest, I'm highly skeptical of hydrogen in general. But you know, just throwing some figures out there for consideration, you know, 99% of hydrogen is essentially produced from gas, oil, or coal. So the talk of getting rid of emissions is dubious at best. And it's a highly energy intensive as well, you know, in terms of the equivalency. And like some figure was saying that the entire oil consumption of Japan is actually right now being used to produce hydrogen. And of course, when we're looking in Central Asia, I'm not entirely sure why do we need, you know, hydrogen here, with all of these issues involved on top of the water consumption, which is also a scarcity in this area. I'm saying Central Asia, but Mongolia is in the neighborhood anyway. Thanks.
Thank you for your question, Luke. Can you?
Yeah, with pleasure, absolutely. Thank you, Muratbek, for that. I mean, I think that you're articulating certain concerns and certain skepticisms, which we hear often. I mean, I think the first thing I would say is, you know, this work is responding to the fact that there is private sector interest in this technology, right? So that means that there are people out there who think that under certain conditions, this is something that can be produced. So it's at the, you know, it's coming from that as our starting point, you know. And so rather than us necessarily going in with an overly prescriptive, this is what Mongolia should do, it's just if you are going to do it, then how can you do it sustainably? I think the other thing that comes out of this work is that, and I mentioned this in my presentation, is that many of the policies that would need to be implemented to produce renewable hydrogen need to be implemented anyway, right? So like when we're thinking about setting a kind of the framework conditions for the adoption of less carbon intensive technologies in industry, or setting the kind of framework conditions that make it more attractive for foreign investors to you know, go into kind of these low carbon industrial development versus the business as usual scenario, whether it's hydrogen that benefits from that or not, it will nevertheless move the needle in a positive direction in terms of the kind of the preparedness of the industrial sectors across Central Asia for the adoption of these low carbon fuels, which eventually they will have to do. So I think that it's also important to take a step back, look at the kind of what's the policy toolkit that's being proposed here, and you see that actually, yeah, it would help the development of hydrogen, but it's also going to help the kind of low carbon transition of the industrial sector generally, regardless of what happens with hydrogen going forward. And then one last point on terms of the demand, I think that's you're absolutely right that just now the vast majority of hydrogen is produced with coal and with gas. It's brown hydrogen, and that raises two questions. The first is that, you know, when you're thinking about net zero in some of those industries that use brown hydrogen, well, there's obviously opportunity to replace the brown with the green. That's obvious. Under what conditions that becomes economically interesting depends on the kind of the questions around carbon pricing, around the access to these technologies. But what you also see is that when you look at Central Asia, I'm thinking of Uzbekistan, for example, that countries are seeing opportunities to find new applications of hydrogen, because in the context of global decarbonisation, for example, in the EU with CBAM, there are opportunities for countries in the region to actually access new value chains. So it's not so much about, you know, just replacing the brown hydrogen with green, but also about what that then gives you to develop new value addition in your economy. So maybe that's in fertilizers, replacing using green hydrogen or green ammonia in fertilizers and exporting that. So it's also creating new opportunities, I think, for countries in the region. So there's two different ways to look at that, I think. But I do appreciate the skepticism and the kind of the caution, perhaps is completely understandable. Green's got.
Yes, I think Pauline wants to comment, so Pauline, please.
Yes, thank you very much. I just wanted to add to an already very comprehensive response from Luke to highlight a couple of points. One is that the question is absolutely legitimate. We do, under current conditions, the state of our knowledge and the conditions of our economies on the global scale, we know that shifting hydrogen production from fossil fuels to sustainable production pathways is needed to achieve net zero by mid-century, because there are some applications for green or renewable hydrogen that cannot, I mean, it offers a decarbonization solution in areas where there's no alternative, at least for now. So that's really the starting point, I think. In hard-to-abate sectors such as steel, such as cement, this is actually needed to really abate carbon emissions in those sectors. And you have such activities in Central Asia. So at some point, even if you don't produce locally renewable hydrogen, you're gonna have to use it if you want to achieve at least net zero. So from that perspective already, I think that there's a virtuous process in place when talking about the potential of this technology and the opportunity of using it in the region, even if in the end the localization of the production is another issue and might not be the most economically sensible and ecologically sensible solution. So there is that benefit. There is also the benefit that Luc was underlining on establishing the policy dialogue around low carbon innovation at large, which we think is absolutely critical to enabling the emergence of sustainable economic pathways in the future in the region. And finally, I also hear your skepticism around the actual ecological sustainability of renewable hydrogen production. And that is very much also at the core of what we have been working on, focusing specifically on the water and hydrogen nexus. But we are also looking to expand a little bit this work under SIPA, but also under another project that the OECD has in the region on the land, energy and water nexus, to also look at the impact on biodiversity and broader environmental consequences of renewable hydrogen production.
Thank you, Pelin. I saw that Luke is very efficient. There was a question in the chat and he already responded. So we will go to follow our timing. And I would like to give a floor to our colleague, Saulia Zhuldayakova. She's actually from the private sector. So she's Hydrogen Energy Competence Center representative from KMG Engineering. So probably she will add some clarity on what's happening on that sector in Kazakhstan. So Saulia, please, you can also share your presentation if you want, and yeah, start your talk.
Thank you very much. Good afternoon, dear ladies and gentlemen. So at first, thank you very much for the invitation to participate to this important event. My name is Saulia Zhuldayakova, and I'm representing KMG Engineering Company, Hydrogen Technology Research Laboratory and Department of Alternative Energy. So we are the first hydrogen center in Kazakhstan, which we established in 2022. It's a hydrogen energy competence center. It was a task by state of government to the Minister of Energy, Minister of Ecology, and National Oil and Gas Company, Kazmunaygas. So KMG Engineering, it is a subsidiary of Kazmunaygas, which focuses on engineering research projects. So to expand our activities, our center was renamed to Department of Alternative Energy. Also, we have Hydrogen Technologies Research Laboratory in Atrau city, in west part of Kazakhstan. Why this center was established? In 2021, National Oil and Gas Company Kazmunaygas announced about low carbon development program. Here is main 4 direction for low carbon development, and the 2 of them are very related to hydrogen sector. It is petrochemistry and energy transition. Why petrochemistry? Because KMG Kazmunaygas planning to produce product of petrochemistry. Here we can use low carbon or renewable, low carbon hydrogen or renewable hydrogen, which means we can produce low carbon chemical products. And energy transition. So KMG have a aim to reduce CO2 emission by 15%. So that's why here is also hydrogen can be interesting. And our department mainly working on comprehensive analysis of hydrogen technologies. So at first we have to understand what kind of technologies now we have. We review international experience, different programs, strategies, roadmaps, hydrogen standards. We are considering blue hydrogen as a low carbon because we are oil and gas company, and green hydrogen as a renewable hydrogen. And we also participating as expert in doing consultations to our parent company on different pilot projects. And actively we are participating to the working groups at the Ministry of Energy to prepare hydrogen concept strategy for Kazakhstan. To implement hydrogen, it is important to understand the role of R&D, research and development. That's why laboratory was established in Atrau city. Here is we are doing our research projects, which are focused on hydrogen storage materials. When we say about hydrogen energy system, we know we have to think about hydrogen production, storage, transportation, and hydrogen utilization. When we established our center, we did a monitoring of current research projects in Kazakhstan. We found interesting projects related to hydrogen project, hydrogen production, hydrogen utilization at different universities, and understood that hydrogen storage, it is open topic for Kazakhstan and also main part of hydrogen system chain. That's why we decide to focus on safely hydrogen storage and transportation system. And it is also a big question for the different companies, countries. That's why we decide to start our research to production of hydrogen storage materials. Our laboratory have a cooperation with local and foreign institutions, universities. As I said, we are R&D the department, and we want to be bridge between academy and industry. Currently, we are working Kazakh German University, Nazarbayev University, Rainer Lehmann Institute from Germany, Tokai University, Japan, and Green Spark Company from Italy. We have several equipment, and now we are started our first experiments on preparing hydrogen storage materials. As I mentioned before, so we have a laboratory which doing research on hydrogen storage materials, and we have a department. The main focus of the department to make analysis, to make research about possibilities of hydrogen in Kazakhstan and especially in carbon gas. So we published already 3 research papers. You can find them. Here is we are considering about possibilities of hydrogen in Kazakhstan. This first paper about possibilities of hydrogen in Kazakhstan, which published on the base of Asian Development Bank. Also, as I also mentioned, as an oil and gas company, it's a first step for the short-term future. We are considering about blue hydrogen production, low carbon hydrogen, and our modeling also was published on the base of Society of Petroleum Engineering. And lastly, we also tried to explain about benefits of hydrogen industry in Kazakhstan. Here you also can find our article in the base of International Journal of Hydrogen Energy. So on those research, we are focusing why we need hydrogen, and we are considering external market and internal market. So Kazakhstan has potential of both blue and green hydrogen because we have natural gas reserves, existing gas injection facilities for blue hydrogen, and also renewable energy sources for green hydrogen production. And according to the International Energy Agency, until 2050, the main hydrogen market will be in European countries and in China. So Kazakhstan, as other Central Asian countries, have access to export, to transport hydrogen for those countries. That's why we think export potential can be one of the drivers to produce hydrogen in Kazakhstan. Also, different international organizations currently working on the research of internal market. For example, according to the World Bank, hydrogen will be mainly used in the domestic market in the production of ammonia, methanol, and steel production. So in our paper, we are focusing main 3 drivers to explain why does Kazakhstan need hydrogen. To be honest, this question is the most popular question, and every day we are trying to explain why does Kazakhstan need hydrogen. So first driver, it is export potential. As I mentioned, here we have 2 main markets, consumers, China and European countries. Driver 2, it is carbon tax, CBAM, ETS. About carbon tax, already previous speaker, Luca mentioned it. And if I'm not mistaken, from this year already aluminium production also included to the CBAM list, and production of such kind of materials will control the CO2 footprint. That's why we have to understand impact to the economy of country, and we have to think about risk of carbon tax. And decarbonization, Kazakhstan also announced about carbon neutrality, signed to this program, announced carbon neutrality strategy last year. And we see like existing decarbonization actions like increasing of renewable energy sources, changing from coal to gas in the power plant. It's not enough because we have a hard to abate sectors. That's why here is we need the hydrogen. In our research paper, we show the time frame for hydrogen in use in Kazakhstan. For short term, it is chemicals and refinery. It's an oil and gas company, Gas, already using hydrogen, but it is gray hydrogen. So we already have an infrastructure to produce hydrogen. However, we have to make it with less CO2. That's why we can modernize, use CCUS technologies, carbon capture technologies, and produce at least low carbon hydrogen. Low carbon hydrogen for us a transition to the renewable hydrogen. That's why for short term, for midterm, we considering the role of blue hydrogen for Kazakhstan. For midterm, steel production, transport sector, and power generation by turbines mixing natural gas with hydrogen can be available. For long term, we see the perspectives in industrial heat, in the ship aviation for transport sector, and backup power system, energy storage system in power generation. However, we have different challenges. I don't want to say it is barriers, because step by step we are trying to solve such kind of challenges. And the first challenges which faced as a private sector, it was legislative point, because we don't have any standards, regulations related to hydrogen in Kazakhstan. So for the safe use of hydrogen, we need standards related to hydrogen. And also as a country, even when we want to import some hydrogen technologies, we need to show how Kazakhstan interested in hydrogen. That's why for now, for example, we don't have clear vision for the future of the hydrogen industry. Stakeholders are not pushing forward the development of the industry. That's why it can be difficult to us to invite different partners. That's why we are currently working with a technical committee, which are working on the developing hydrogen standards. We are doing our recommendations. So last year, 7 of the standards was under consideration and 3 of them approved. So it is standards about hydrogen quality, second one about safeness, and third one was about hydrogen systems. And I hope the first step with those standards can help us to realize our first pilot projects. For this year, we also did a recommendation. Around 17 standards was selected, and we are waiting the results. How many standards will be approved? So also we have to understand that Kazakhstan have to prepare our own strategy. For now, almost 50 countries already announced a strategy, roadmap, and the first country which was with hydrogen roadmap, it was Japan in 2017. So for now, almost 50 countries have strategies, and a few months ago, a Minister of Energy of Republic Kazakhstan announced the first draft of the hydrogen energy development concept until 2040. We are also working with this working group. We did a recommendation, especially to consider a role of hydrogen not just for external market, about support to organize to start internal market also. And this concept, considering not just industry side, it's also about academy, about R&D project, also preparing of the specialist, which during the question sector, Madina mentioned. So the second challenges which are faces as a private sector, as a company, it was the technical problems. So we have to create a value chain from zero, and we need infrastructure. So currently we are working on the development of technical economical calculation on the production of blue hydrogen. And here we see the current situation. It is limited demand for hydrogen in Kazakhstan, because currently only 2 refineries use gray hydrogen in Kazakhstan. It is refineries in Atyrau and in Pavlodar cities. Also, the existing industrial infrastructure does not allow for the use of hydrogen without extensive modernization, especially energy sector. And we see there is no demand of low carbon hydrogen because of the cost. gray hydrogen, it is cheaper. So as a resource, we are considering natural gases on the gas fields, oil fields, and gas condensate fields. We are working with limiting factors. We are working with subsidiaries of companies, potential hydrogen users, such as refineries plants, and we are also monitoring fields of gas production, their plans for gas utilization. And we won't give them recommendation to use produced gas, natural gas, to produce hydrogen. So the third one was related to lack of competences. So this point also already mentioned during the question section by the first speaker also. So lack of competences, lack of specialists. Yes, we need specialists who will understand hydrogen energy system from the start, from the production to the utilization. But for now, at least we have to prepare already existing specialists and change them to the hydrogen field. That's why we are organizing introduction, educational training, seminars to employees of KMG engineering. And from last year, we started to organize such kind of seminars to all employees of KMG and all subsidiaries. We invite in representatives of different companies, research institutes, international organizations to share more information, more knowledge about hydrogen. And it is important also to train our own specialist employees, and our specialists visited Japan, Germany for the different training programs, seminars to understand more about hydrogen energy system. And recently, our colleagues also visited Germany for the training related to assessment of water resources for hydrogen production, because water is one of the big challenge is environmental, from the environmental side. So production of green hydrogen and production of blue hydrogen, both of them need water. And we have to understand the current situation. For example, flooding in some region of Kazakhstan, water shortage in other region of Kazakhstan show us that we need carefully manage water resources. That's why it's a first step. We wanted to make assessment of water resources for hydrogen production based on qualitatively analyzed data on the water resources, as well as the existing potential of renewable energy sources to understand green hydrogen production, and visualization of estimated data on the availability of water resources in certain region. For example, we started from the west part of Kazakhstan and analyze various hydrogen production scenarios. So we have to understand how many waters we have, how many waters we can use to produce hydrogen, and how many electricity from solar or wind we need to produce hydrogen. In the end, we want to understand the cost of green hydrogen production in Kazakhstan. So for today, I think that's all. We are interested in the different topics. We are working on the analysis of production, green, blue hydrogen production. We want to know not just case of Kazakhstan. We are open to collaborate with Central Asian countries, with Mongolia, because we have like similar situation, climate condition, and we have similar maybe challenges. That's why we are open to cooperation, to partnership. So here is my contacts. You can contact me. So thank you very much for invitation. Көп рахмет, чон рахмат. And if you have any question, I will be happy to answer them. Thank you very much.
Thank you very much. Saulesh is one of the representatives of the young scientists we're proud in Kazakhstan. So thank you for a very timely presentation. And we wish good luck to all of you. But I think in your lack of competences, you have to include the civil servants. Because if you want your new standards and norms and legislation to be approved and really well understood, we have to also work on with the mindset of our civil servants and decision makers and policy makers. Because to be able to develop a comprehensive policy, they really need to be knowledgeable of how it works and be in contact. So we will be in touch with you if we decide to do any capacity building for the civil servants in Central Asia to really foster the policy environment. We will be happy to contact you again. So we have a question from Krishing Tamir. Please turn on your mic and ask your question. We have 10 minutes for the Q&A and then we will continue. Please shortly introduce yourself.
Okay, thank you. My name is Krishing Tamir. I work at Newcom Group in Mongolia. Our company is a private company, investment company, actively works in the energy sector. And I would like to thank to Dr. Saule Zoldayakova for the interesting presentation. And yeah, the hydrogen industry is, of course, it is in its early stage of development. And my question is regarding the estimation of water needed for generating per kilogram of hydrogen, and your figures are appearing like 9 to 11 kilogram of water for producing 1 kilogram of hydrogen. And I hesitate whether this estimation is not based on the raw water from the nature, but it might be the demineralized water already prepared to be used in electrolyzer. Is that correct? Yeah.
Yes, that is correct. Here we show the clean water. So it is like from the chemical formula. So 1 kilogram of hydrogen, it is 9 kilogram of clean water. However, in my slide, I showed that from 9 until 18. So in the case of, for example, wastewater or seawater, it will be doubled, maybe twice or 3 times. So it will be depends on the purity of the water. So it means like, for example, I don't know, did you hear or not, Kazakhstan also planning to realize huge project, SIVINT. It is not our project, it is by private company from Germany and Swiss, if I'm not mistaken. And for example, they are announcing to produce 2 million tons of green hydrogen in Caspian Sea. So it means Caspian Sea have a salt water, so we need a desalination process. So in that case, we have to understand like just it will not 2 million tons of hydrogen equal to the 20 million tons of water. It will be more than 20 million tons of water because we will need purification, we need desalination. And also it will be depends on the salty of water. In the case of wastewater, also it will be depends on other like characteristics like pH and other. So that's why, for example, I mentioned in our research, we are focusing water resource survivability. For example, west part of Kazakhstan, we understand we don't have enough water to produce green hydrogen. However, we have a chance to produce green hydrogen from wastewater. It is the next step of our research where we want to try to understand how many hydrogen can be produced from wastewater in the region, because west part of Kazakhstan have different industrial sectors, plants, and they have a lot of wastewater. So using wastewater to produce hydrogen also can be a good way for water management to use water more effectively.
Okay, thank you, Dr. Saule. And if you are able to send us your presentation, then we can send you email and we can ask more questions, or we can provide you more information regarding the pilot projects implemented in UK next to the wastewater treatment plant, which was producing the hydrogen, and it was somehow very effective to the treatment process of the wastewater treatment plant.
Okay, thank you very much.
Thank you.
Thank you very much. We're happy to see that we're already linking some experts. I see the hand of Pelin. Also, Pelin wants to comment. So, Pelin, go ahead. Thank you very much for your question.
Thank you. I just wanted to specify if Dr. Zholdayakova, when you say between 9 and 18 kilograms of water per kilogram of hydrogen produced, that's only for the electrolysis reaction, correct?
Yes.
Because it does not take into account as well the water that is used for cooling purposes.
Yes. Yes.
We have done an estimation just for everyone's benefit in the work that we did in Mongolia. We estimate that in total 40 kilograms of water would have to be abstracted to produce 1 kilogram of hydrogen, considering the use of saline groundwater that needs to be pre-treated then before the electrolysis reaction, as well as a part of that water that will be needed for cooling purposes. And that is, of course, what is needed to produce hydrogen under its gaseous form. But if you want to produce ammonia, then you need an additional amount of water to transform, to embed the hydrogen into a molecule. So just to say that when talking about water estimates, it's important to really specify the scope and what is envisaged. You could some experts also take into account the amount of water that is required for renewable energy installations. For example, the water that is used to clean solar panels, which can also vary from region to region. And thank you very much, Dr. Zholdayakova, for a very interesting presentation that resonates a lot with a number of issues that we're exploring in the framework of the work that we've done in Mongolia, and some of the solutions that you are talking about for addressing this water and hydrogen nexus, including the usage of wastewater, also looks very promising. I would go into even one step further to say that there is scope to think about this co-location of infrastructure and these hydrogen hubs as an opportunity for diversification at the sub-national level, so really at the regional level, creating more quality jobs, enabling a transition, a just transition by creating new green jobs, and thinking of agglomerations economies, but also circular economic principles by reusing water that is wastewater produced from industrial activity, and using this wastewater to produce hydrogen. So a lot of interesting ideas and thoughts there as to how to establish a business model and an economic model locally for and taking advantage of this green technology. And it was really great to look at KMG's work in this area. So thank you very much.
Thank you.
Thank you, Pelin, for your comment. So given we're talking about Kazakhstan and there was a huge flooding, so we have to consider about stormwater collection if we are lacking the water for this kind of purposes. So thank you very much, Saulia. I want to proceed with the next presentation, and I would like to give a floor to my colleague, Ablay Dosmakambetov, who is going to talk about some preliminary findings on the investment in the so-called clean energy infrastructure, and that's what we find so far. And so please, the floor is yours.
Thank you, Marina. Good afternoon, everyone. So I welcome you all for this presentation, which is all about decarbonization of energy in Central Asia. So before we proceed, I'd like to briefly mention what this presentation will be about. So this is basically ongoing project, ongoing work for now. And first we'll consider what is the study is all about, what is the purpose and the target. Second, we will touch upon what is like a study workflow for now. And we consider other further steps of this study. We'll also consider some regional energy dynamics, as well as some insights from energy infrastructure investments in this Central Asian region. And we'll conclude with some preliminary findings, with some kind of thoughts for the future study as well. So let's start. And this is like in brief about the study. So actually the study targets to kind of evaluate, right, the policy environment in the Central Asia in terms of its contribution of to energy decarbonization, and how, like, to better understand to what extent, like, investment patterns and trends actually affect this energy decarbonization in the region. The final outcome of this research will be the background paper report, which will consider actually key trends and patterns of investment projects in energy infrastructure, as well as some policy recommendations for 6 Central Asian countries in the region, and which will be based on identification of the key challenges and some possible opportunities as well as solutions. So I'd like to also briefly mention about the phases of the study. So for now, the phase 1 and phase 2 are almost like underway and completed. So now we are turning to the phase 3, which I'll discuss in a bit later. So in detail, phase 1 actually considered gathering and preparing a kind of aggregate data set of investment in energy infrastructure projects, investment projects for 6 Central Asian countries, namely Kazakhstan, Kyrgyzstan, Mongolia, Tajikistan, Turkmenistan, and Uzbekistan, over 16 years. So the study covers a period of 2008 to 2023 inclusive. The second phase actually was all about making a preliminary data analysis to, like, kind of get the whole, like, aggregate, at least whole picture about what is going on in the region in terms of investment projects and the financing of different projects in different kind of energy infrastructure types. So next step will be about providing a literature review on energy decarbonization with particular focus on Central Asia, and include some additional data as well as analysis related to more kind of traditional source of energy, or let's say carbon intensive energy projects, which include oil, gas, and coal infrastructure projects or coal projects. But let me also notify here that to some extent some gas infrastructure projects already compiled, and there is some information about that. So we need to focus more on coal related projects in the region, and to some extent maybe oil related projects, especially with particular focus in Kazakhstan, because it's the main country which considers a producer and the consumer of oil. Phase 4 will be about identification of key challenges and opportunities for energy decarbonization in Central Asia. And the final step will be about outlining some policy recommendations based on the findings from data set, as well as probably some reports, as well as some possibly from primary data as well. So let's turn to some regional energy dynamics first to get the whole picture. Here on this slide, we can see this CO2 emissions tons per capita for all 6 countries in the region. Basically, we can see that the most of the CO2 emissions come from 2 main countries in the region, mostly Kazakhstan and Turkmenistan, which is also followed by Mongolia, and Tajikistan is considered as less intense and more kind of stable, low CO2 producer of CO2 emission in the region. If we turn to another more kind of detailed and specific country cases. Here we can see CO2 emissions in million tons for 6 entire countries. I'd like to just mention that most of the coal CO2 emissions from coal, like use is like in Kazakhstan, as well as there is upward trend in Tajikistan and Mongolia. Kyrgyzstan experiences some fluctuation trend over time from 2008 to 2023. And the gas, like extremely, like CO2 emissions from gas sector extremely high in Turkmenistan, like which is logical way, like one of the biggest producers and users of natural gas in the region, as well as in Uzbekistan. But regarding the oil, this more interesting that in Kyrgyzstan as well as in Tajikistan there is upward and to some extent stable trend over entire period. So now if we turn to more specific kind of study and analysis which we are making in our kind of project right now, I'd like to stop here a bit and explain the details so that it will be like for you to get more details other than the information on the presentation. So currently we're considering investment projects and let's say initiatives in low carbon energy infrastructure side. So we are now on the phase 2, as I mentioned like before in the beginning of this presentation. We're considering different projects which we grouped like based on the current like data available for 3 main clusters: the energy efficiency projects and renewable energy projects, as well as other energy related projects. The reason of doing that is because there are a lot of types and sectors of the low carbon energy infrastructure. And by many, I mean like there are a lot of energy efficiency projects. For example, there are a lot of projects related to energy efficiency in, let's say, public buildings and residential buildings. Some energy efficiency projects in lighting case. There are a lot of projects, for example, energy efficiency related projects, investment projects in efficient electricity transmission. So as there are a lot of around 17 sectors and types of let's say energy infrastructure projects, it was good like to group them into 3 main aggregate categories. In the renewable energy projects, we include solar power plants, wind power plants, hydropower plants, or combination of them. There might be some projects which include both solar and wind power plants. So there are these renewable projects in this category, and other energy related projects include, for example, projects which require equipment for better electricity transmission, let's say, right, or better grid optimization in the region. But on the right side of this presentation, this will be the further step in the future study. As I mentioned, we will consider, let's say, infrastructure projects, investment projects in traditional source of energy, so that we will get the whole picture of what is going on in the region, not only low carbon energy infrastructure projects, but also carbon intensive energy infrastructure projects. So this phase number 3 is ongoing right now. Some gas energy infrastructure projects are already in the pipeline. Now let's turn to dynamics of investment in energy infrastructure projects for 16 years for the 6 countries over 16 years. Here is the dynamics as represented in this graph. Has a fluctuating pattern over time. Clearly, we can see that after financial crisis of 2008 and 2009, there is no much like any like changes in the investment related patterns and trends over time, up until let's say another big event happened in 2019. COVID-19 pandemic changed the pattern significantly, and we can see that now Uzbekistan, let's say, had a leading role over let's say 4 to 5 years last year. And there are also some spikes before 2019 COVID-19 pandemic, which happened in 2018. This might be because of the political regime, opening the borders for investment opportunities in the country, in Uzbekistan. The second best, like let's say, doing is Kazakhstan. As you can see, there is an upward trend from 2017, but again, after COVID-19 pandemic, there is like a significant drop down of all investment patterns of 5 countries, except Uzbekistan. So another preliminary analysis is about, let's say, a distribution of investments in energy infrastructure by sectors. Again, as I mentioned before, we can see from this kind of analysis over 16 years that energy efficiency projects constitute a large portion of the 3 main categories here. Aside some years, there is like dominance of the renewable energy projects. But what is interesting is that the last couple of years, from 2022 to 2023, there is a huge attention and let's say interest in promotion of renewable energy projects in the region. So another analysis which we considered here is about distribution of total investment by sectors and countries. What is also interesting is that in the previous slide, where I presented dynamics of the 16 years, here it also confirms to some extent, so that like we can see that Uzbekistan, let's say, owns almost or like less than half of all investment projects in the region. The second like best in the sample, in our sample of 6 countries, is Kazakhstan, which own like about 1/4 of all investments in energy efficiency projects as well as in renewable energy projects. And that Tajikistan, like let's say, owns like 14% of all energy efficiency projects as well as 30% of renewable energy projects. If we turn to another analysis here, we can consider the distribution of investment in energy infrastructure in low carbon intensive infrastructure by donors. So far we included mostly external financing in terms of multilateral development banks. So in the region there is a big, let's say, huge dominance of let's say the 3 main multilateral development banks, or World Bank, Asian Development Bank, as well as European Bank for Reconstruction and Development. So as a graph also in the data suggests so far, there are a lot of huge interest over 16 years, and let's say as well as investments in the Uzbekistan economy, and as well as promotion of clean energy sector. So as you can see, like World Bank owns like almost 3/4 of all investments out of 6 countries. Asian development banks also like invested in different forms of financing, so loan, grant, as well as technical assistance of almost 50% or half of all the investments in the country. What is interesting, like that, for example, we also considered Chinese entities' investments in the region, and now we can see that almost 3/4 of all investments went to Kyrgyzstan in promotion of low carbon intensive, let's say, energy infrastructure projects over 16 years. If we turn to national governments' investments in clean energy and low carbon intense energy infrastructure, we can see almost equal distribution, except Turkmenistan. Now let's turn to another like finding so far and analysis, where here we can consider total investment in energy infrastructure by let's say by source, by donors, as well as by sectors. Also, what is interesting so far, it also supports the previous slide where I mentioned that in the region, energy efficiency projects, let's say, are more kind of interesting, and like there's a lot of potential and let's say attention to that kind of projects. And this analysis and this graph also support this, let's say, evidence, numerical evidence, quantitative evidence. And as can be seen, at least like half or even more of all energy efficiency projects financed by multilateral development banks, as well as national governments and Chinese entities, Eurasian Development Bank. To some extent, there is a high interest in renewable energy projects by other sources of financing and funding, which include UNDP, Green Climate Fund, Japan agencies, and the other entities. So they're included in other sources. But in general, for example, we can consider that renewable energy projects, let's say, are mostly financed by EBRD and the EDB and also to some extent to EDB, Eurasian Development Bank. So I'd like to just finalize this presentation with some preliminary findings, what we have observed so far, and say some kind of provide some examples of big mega projects in the region. So overall trend suggests that over 16 period of time, years, the energy infrastructure investment trend tendency across 6 countries has a fluctuating pattern. So there is no exact let's say, upward or downward trend over time. As I mentioned before, just in the beginning of the energy infrastructure investment analysis, Uzbekistan had emerged as a leader in attracting investments in low carbon projects so far, while the other countries exhibit shares similar patterns. And by this, I would also like to include that, for example, in case of Uzbekistan, there are a lot of projects, mega projects. Let's say one of them is Uzbekistan Bash wind power plant project, which is financed through loan and constituted 710 million in terms of financing. Another big project is Sharabat solar power project, which constituted amount of investment of 390 million in terms again loan. So as you can see, there are a lot of projects in the wind, solar, and to some extent the electricity transmission, let's say, sector of low carbon energy projects. Now, if we say about the sectors or types of projects which we are covering right now, amongst 3 types, we like to mention that energy efficiency projects hold a significant share among the others, except renewable infrastructure projects, infrastructure investments. Now, let's see, has a sharp increase over the last couple of years. There is probably will be shift of trends in the near future. And here, Kazakhstan and Uzbekistan are doing good, and they are doing notable as a primary recipients of this kind of investments in the region. And as I already mentioned, big mega projects in Uzbekistan. Now I also like to just say some mega and the big projects in case of Kazakhstan. So for example, there is a big project called Kayevka Energy Efficiency Project, which is financed against a loan, which constituted 660 million US for this kind of project separately. Another is modernization of electricity transmission lines of Kigok quasi-state enterprise. The second phase of it constituted 375 million in terms again loan. And finally, for example, there is also a big project called Turgun 3 hydropower plant construction, which again constituted a large portion of share of 250 million of US. Now, finally, I would like to just conclude and make some notes about donors. So far, what we can see is that the distribution of investment by donors and countries, let's say, points out that Uzbekistan considered as the main beneficiary in the region. So Uzbekistan benefits a lot from let's say, investments mostly in solar, wind, as well as optimization of energy, transmission, modernization of electricity transmission lines. Concerning the donors, again, multilateral development banks, national governments, as well as Chinese entities, made a lot of investments in energy efficiency projects in the region, and this probably pattern may continue in the foreseeable future. Yep. So by this, I'd like to conclude my presentation, and thank you for your attention. If you have any questions, please address it. Thank you.
Thank you very much, Abulai, for this interesting presentation. And we are open for discussion, questions, comments. So if you have questions, you can, raise your hand or use the chat area. And as Abulai mentioned already, it's ongoing studies, so it would be great to get your feedback and some maybe suggestions and to improve the quality of the study. And also we're planning to conduct several expert interviews. So if you are knowledgeable of people who could actually open up some new investment projects in that area, we would be happy to communicate with you. Yeah, so do we have any questions? I don't, yeah, I think Pelin wants to add a comment. So please, Pelin, go ahead.
Yes, I would just like to jump in because if I may, what we see in this study is that the pipeline of infrastructure projects currently does not allow to be confident about the fact that the region will achieve its national determined contribution objectives. And I think it could be great if Abulai could perhaps elaborate a little bit on what would be the main avenues, what are the main issues that the study highlights and that need to be addressed from the perspective of policymakers, and where the regional discussion can actually help.
Okay, thank you, Pelin, for your question. Yeah, so because we're considering right now just a preliminary study, as I mentioned before, on next phases we'll consider more kind of analysis of challenges in the region, and some kind of opportunities, as well as solutions for overcoming this, let's say, carbon intensive nature in the region, right? But so far, it can be said that one of the biggest challenge here is lack or absence of expertise or skills and promotion of next one I think is about infrastructure. Is very important in the region, because today there are a lot of let's say outdated or old infrastructure in the region, even for traditional source of energy, which makes emissions even higher, right? Because there needs a lot of investments in reinvestments, let's say, in the upgrading and making this old infrastructure better. And I think that another big obstacle and issue is about governance as well in the region, because there are a lot of probably complexities in terms of documentation, providing expertise, some kind of legislative bindings, and some regulatory, let's say, even frameworks in the region. So this kind of let's say factors probably considered as impediments in the region. But this further challenges and opportunities, of course, will be specified in the later phase. So far as just general, let's say, knowledge about the region. Yeah.
Thank you very much, Abulai. I think there was also a question, what is the trend for the next 10 years for Central Asia?
Yes, thanks for the
and
question.
Also Murat Bek's question.
Yes, so concerning this, some kind of trends, it seems that it requires some investigation, because now we are like did mostly like let's say as is, so what we have right now, right? So we're considering the past tendencies over 16 years, but let's say it will be again covered in the future studies. So we need to probably refer to some agencies on their projections and let's say their like let's say prospective studies on this region. But it seems like if we consider over 16 period of time, through iteration, right, we can say that probably countries which let's say has this advantage. For example, Uzbekistan has a lot of advantages, kind of promotion of solar energy in the region, right? So there might be upward trend in investment in Uzbekistan even further, especially in solar promotion of solar power plants in the region. For example, in Tajikistan or Kyrgyzstan, there might be upward trend of investment in promotion of small-scale hydropower plants. So I think that every country will utilize its own competitive advantage in the region, and this might also increase investments in the region, because considering that mixed kind of investments in the country, I think it will be a good strategy for each country. Hope I answered, but there is no exact numbers right now which I can say for now, but we'll try to address this question in the later stage as well. Thanks.
Thank you. If there are any other questions, I just want to add a couple of comments based on the study of this energy sector development in general in Kazakhstan and Central Asia. I think the big issue is like even listening that there is a new strategy on hydrogen development. We see that there is still sectorial type of a very narrow perspective on this infrastructure, and we really wish that on the Central Asian country there will be a solid strategy of energy sector development as a whole, including all this, you know, how they're going to transit from this carbon to renewables. And unfortunately, I think in most countries it's pretty centralized, and it's actually increased you know, this complexity of using it as a clean energy. So actually clean energy goes to the grid and become, you know, mixed with the brown energy, and we don't yet understand if we're using the clean energy or not. Yeah, so this is another factor, and as we all see that what's happening is that we have, even in Kazakhstan, we have a decarbonization strategy, but we don't yet have a clear action plan or implementation plan, and it's related to many factors. And I do agree with my colleague that we should work both with demand and supply side. So we can always be reactive to demand, and it will be growing due to the lack of energy efficiency, or we can work on both sides and we can decrease demand by increasing energy efficiency of all industry and make it more greener. And so it's have to be a very high level political discussion, and I know that OECD is doing their best to create this regional policy discussion around the comprehensive approach or integrated approach to solution of these problems, not to look at only specifically alternative energy without understanding that actually there is a common infrastructure used for both the brown and clean. Yeah. And we have a question, I think, from Alexander. So please, before asking your question, introduce yourself, and you can turn on your mic. Alexander, you can speak. Turn on your mic and please introduce yourself.
Yes, thank you. My name is Alexander Timirbekov. I am currently engaged by UNDP to overview the previous NDC development and to sum up recommendation for NDC 3.0. Additionally, I'm currently working with the Central Asian Institute for Applied Geosciences to develop a national adaptation plan. And But I want to speak not about my current undertaking. So as you can imagine, NDC is the main prerequisite for continuous green investment, regardless of their source. What I want to stress is the fact that according to UNEP, DTU, Danish Technological University publication, success of any technology deployment and diffusion is the availability of the three main factors. Hardware, so we know where to buy it. Then goes know-how, skills to maintain, to proceed to develop. And the third, the institutions, including both public and private sector who are ready to maintain, develop, I don't know, spare parts, manufacture spare parts, etc., etc. So that is why I think with that such sophisticated technologies like hydrogen, for instance. By the way, Kyrgyzstan considered this rather promising undertaken or action, transformative action in terms of reaching carbon neutrality. And maybe you know, last year this long-term carbon neutrality strategy has been drafted in Kyrgyzstan, and the hydrogen for vehicles is an additional action to achieve it in the next decade, starting from the next decade of 2030, 40, something like this. I do not remember by heart. However, this valuable initiative, they need more attentive I would say research, and it is great that University of Central Asia undertaken this. But I would say that what is needed in Kyrgyzstan very urgently is the climate finance target. We've got a lot of projects dealing, as we see, with climate. And I don't know the criteria that has been chosen to absorb climate infrastructure investment. But I got strong suspicion that the word climate resilient infrastructure was a rare attributive to that of this project. We've got a lot of development projects. Yes, this we have, and the task of finance experts to evaluate them on the possibility to attribute them to the really climate-related finance. Thank you very much.
Thank you very much for a very comprehensive comment and feedback from Kyrgyzstan. It's also good to learn what's happening there. And yeah, so I see that Ablai is very efficiently responding to some questions he was obtaining via chat. So if there are other speakers, I mean, if someone wants to comment or ask a question, please go ahead.
May I ask?
Okay, sure.
For another presenter.
Yeah, by the way, this is an overall discussion. Okay. So it's if you have questions not only to Ablai, but also the previous speakers, you can jump in. And we see Ablai already has a question to the previous speakers. So please.
Thank you, Madina. So my question to Luke. Luke, first of all, thanks for your interesting and insightful presentation. I've had a chance to ask you during this Q&A for your particular session. So you mentioned that one of the most important part for promotion of hydrogen in Mongolia is about technology transfer, and you said it's that's also let's say one of the way of the promotion is attracting of foreign direct investments. And you in your presentation you provided the dynamics of FDI, sectoral FDI in the Mongolia over a couple of years and dynamics of it. So as I remember, there is a very little investments in hydrogen, and you also mentioned that there is so-called FDI restrictiveness index. So in your opinion, what is the main restrictions in promotion of FDI for hydrogen development in the Mongolia? If you comment that, it would be great. Thank you.
Thanks, Abdullah, for that question. I think there was maybe a little bit of misunderstanding about the graph. So just to clarify, I think the graph that you're referencing, the slide that had the graph, there was two sets of charts. On the left-hand side, there was, as you mentioned, the FDI Regulatory Restrictiveness Index, which is an index that measures the statutory restrictions on different sectors of the economy, and that was on the left-hand side. On the right-hand side, it wasn't actually a graph about investment. What it was a graph showing the planned electricity generation expansion that was foreseen by the Ministry of Energy over the coming 15 or so years, right? So it wasn't specifically a graph on investment, although it does obviously have investment implications, but that was not what that graph was showing. Although we do discuss some of the investment dynamics in the report. You are right, though, that of course there's very little in the way of investment in hydrogen technologies. I mean, that is true for Mongolia. It is true for most OECD economies, right? It's not Mongolia, Kazakhstan, Uzbekistan are not outliers in this regard. They're very much part of what is a very nascent technology development, and so statistics about kind of FDI inflows in this are not really there yet. And when these things are happening, often it's we were listening to our colleague from KNG Engineering. It's investments that are happening within firms, firms are already in the territory who are then investing in these technologies through R&D. So it's not necessarily going to show up through the FDI statistics. To your question on what would be the kind of the barriers to this, I mean, if you're thinking specifically about Central Asia, then the barriers, I guess, yes, there are some regulatory barriers which are not, again, unique to the region. It has to do with the fact that, again, as the colleague from KNG was discussing, much of the regulatory framework that is necessary to license and to permit hydrogen production, storage, transport, use in industry doesn't exist yet, right? So the regulatory framework that is necessary to operationalize these investments doesn't exist, and this has to be created, and so firms are not going to invest in large-scale hydrogen applications in the steel sector or other metallurgical activities if there is not a regulatory basis for doing so, right? And so there are these conversations going on in order to establish that. There's another regulatory aspect which is involved, which is many of these projects that we see in Central Asia, as we see in other emerging economies, are hydrogen projects where the developers are looking to produce hydrogen or its derivatives for export, right? So eventually they want to export it. And that also means that what is produced has to be coherent with the standards and the certification that govern external hydrogen markets, right? And so long as that regulation, that quality infrastructure standardization certification has not yet been fully articulated, then investors are going to hesitate, especially when they see that the projects that are happening in the territory are not necessarily aligned with the direction of travel in those international regulatory kind of things. And then the last thing is, it's not so much hydrogen specific, although partly, when you look at infrastructure questions, hard infrastructure questions, there are, of course, kind of, considerations there, but there's also a kind of chicken and egg scenario, right? Do you invest in the infrastructure before you have a production capacity? That's a difficult thing to think about. But more broadly, and this is what we try and discuss through our work on Mongolia, as we do in all our SIPA work in the region, is are the signals from policymakers going to give a clear message to investors that the countries are genuinely committed to a low carbon transition, right? So are the various parts of that framework, coal phase out, carbon pricing, the investment policy framework that kind of directs investment towards low carbon initiatives, so that's like, subsidies for the capex that you need for these things. Are these things all pointing in a direction that say, yes, actually, we see the next 10, 15, 20 years as this being the direction that we want the FDI to go in? Or are the signals still saying that we prioritize, investment activity in these carbon intensive sectors, oil and gas? And for the time being, I would say there's a question mark over whether, what kind of signal investors are getting from the governments in the region. So that's not so much a kind of regulatory barrier, although it does have regulatory aspects. It's more about what is the overall investment kind of climate saying to investors about the seriousness of the government's commitment to these new technologies.
Thank you. Thank you for your comprehensive answer.
My pleasure.
Thank you, Luke, for very interesting discussion we have. Actually, we're very close to closing time, and I think let's do some concluding remarks. So, of course, definitely we're going to upload all the presentations on our website, and we will inform you when it's available. So no worries about missing this information. And I want to give a floor to Pelin for the concluding remarks and maybe informing about any news related to the energy decarbonization and what OECD is doing. Thank you.
Thank you, Madina, and thank you to all the presenters and the participants and all of you who attended this webinar for a very interesting and fruitful discussion. We see that there's a number of challenges that were mentioned today with regards to legal obstacles in the fields of skills, of infrastructure, of investments. But those challenges are not, some of those challenges in the form that they take are specific to the region, but most of those challenges are shared challenges with other regions as well and other economies. And so I just want to say that I think it's very valuable to have these conversations at the regional level in Central Asia, but that what we are also trying to do through SIPA is to bring the experience of other countries and of other regions that are facing similar challenges, which we hope can help find solutions and advance on those very complex issues. So in terms of SIPA, we have a number of next steps. A lot of all our partners are mobilized to continue to help with the development of sustainable infrastructure with learnings that apply across sectors, including, of course, the energy sectors. We have already delivered 2 studies on savvy assessments of pilot infrastructure projects together with our partner IISD, which include sustainability criteria, which should definitely be used in the context of energy infrastructure investments. And here I just want to flag one of the risks that Central Asia is facing, along with other regions again. But I think that when we look at the pipeline of projects and think about the outlook, there is a risk of carbon lock-in in the way that those energy investments are envisaged today, a high risk. And so this is clearly something that policymakers in the region need to consider. And so I think this savvy tool that was presented at the last SIPA summer school, I think can be really helpful in this regard, and taking this cost and benefit analysis approach, something that we have together with the University of Central Asia promoted during this last summer school, is clearly indicated for future reflections on infrastructure planning. We're also with our partner, the French think tank IDRI, specialized on deep decarbonization pathways, supporting strategies for low carbon development across the region. We're participating in Kazakhstan, in Uzbekistan, and in Mongolia in exercises being supported by international partners to develop visions that are at various stages of development. So this is also something that we are pursuing and which can provide an important strategic framework for the decarbonization of energy. We've worked together with IISD, another team within IISD, on fossil fuel subsidies, and we're also developing some knowledge in the framework of a discussion we have in Kazakhstan about setting carbon pricing trajectories in the region to incentivize investment in low carbon infrastructure. And this will be fundamental to switching from fossil fuel energy to cleaner energies in the future. So I think that this topic is also very important, and we will be developing more on this, including in our upcoming summer school in end of September, beginning of October in Astana, and the University of Central Asia is leading the effort to organize this upcoming event, and we're very grateful for that. We will continue to disseminate the findings of our work on hydrogen in particular, and there's a lot being done on this topic. It's true that it benefits from a certain hype, but again, beyond the potential of this specific technology, it also has the merit to put a number of important questions at the center of the discussion. So again, it is about renewable hydrogen, but not only renewable hydrogen, it's about low carbon technologies at large and cleaner energy systems. Luke and I will be traveling to Kyrgyzstan and to Tashkent in the coming 3 weeks, and we also give you this rendezvous after the summer for our summer school, our regional summer school in September and October. So stay tuned and thank you very much. I see that we have one hand raised, Madina, so I don't know if you want to give the floor to one last participant before we wrap up.
Yes, sorry, Begali, I will give you a floor. Just give me some time to make a small announcement. So after Begali will share his comment or question, don't leave, please. We want to have a group picture, and let's do it immediately. So turn on your cameras, whoever wants to be in the group picture, and let's make it. And then it's take just 2-3 seconds. And then we will go to Begali. I just don't want to hold the time of the people who is limited in their time. So please turn on your all cameras, and let's have all your nice faces in the group picture. In Begali, и уберите тех, кто не включил камеру. Exclude. Hide non-video participants. Yeah. Okay, I see you all. So I think some people are joining. They're trying to look good. I think you all would look good in this area of energy transition. And so if you're not looking good this webinar, I hope you will be even better next time. So don't worry about your appearance. We just want to have it for our personal archive. So turn on your camera and okay, if you're ready, let's do it. 1, 2, 3, smile. So Zubek, could you fix it? Well, I think some more people are joining. No? Okay. So now we can go to the right hand. So Begali, Sophie, you please introduce yourself before you ask your question or give a final comment. You can turn on your mic. Begali, Sophie, we are looking for your question or comment. Can you hear us? Turn on your microphone, please. Okay, maybe you'll type a message for him. Sophie, can you hear us?
I'm wondering if this is perhaps an unwanted raised hand.
Okay, so conclude, and my apologies if there was a technical issue that we couldn't give a floor to Sophie, but we always welcome you, have our contact email, so you can write any follow-up question or comment. And thank you very much for your participation. We will keep you informed if you responded that you're interested in our future events. So we will be inviting you for our future events, and keep your eye on our website. We will have more interesting announcements. Unfortunately, we couldn't run the policy brief competition on energy transition yet, but I think we still have a chance to raise funding and do it. So get ready with your projects, and there will be some more opportunities. So thank you very much for your attention. And on this note, we are closing our webinar. And I would like to appreciate our speakers. So thank you very much for your speech. We're very well organized and informative, and we will do our best to upload it on our website with your permission. And yes, and thank you very much for our active participants who asked questions and also participate